Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at linear patterns. We're going to be looking at these things here called tables of values. So you'll have two rows, a set of x values and a set of y values. So x is like the input value that you input into a formula and y is the output value. So we're looking at whether the relationship between x and y is linear. So you can tell that very easily. The pattern is linear if each time the x value increases by 1, the y value increases or decreases by the same amount. What do I mean by that? Well, if we look at this table here, as you go from left to right, the x values are increasing by 1. What's happening to the y values? Well, they're also increasing by 1. Each time x goes up by 1, y goes up by 1. So this here is a linear pattern. I'll give it a tick to show that it is a linear pattern because y is going up by the same amount each time. So here, it doesn't matter where x starts, whether it starts at -2 or 0. All we need to know is each time x is going up by 1, y is going down by 2. We're minusing 2 from y each time. That means that this is definitely a linear pattern because y is going up or down by the same amount each time x goes up by 1. It doesn't matter if it goes up by the same amount each time or down by the same amount each time. That makes it linear. Here we have an example of a pattern that's not linear. Again, we have a set of x values and y values. So each time x is going up by 1, so that's the same as in the previous examples, but y is not going up by the same amount. It goes up by 3 here, then it goes up by 4, then it goes up by 5, then it goes up by 6. Y is not going up or down by the same amount each time, so this is not a linear pattern. So why do we call these linear patterns? Well, we have an input and an output value. We recognize these as points. We can plot these on the Cartesian plane. -2, -3 is a point on the Cartesian plane. If I were to go and plot it, it would be like down here. So I can do the same with the next set of values. These two are paired up, input, output. So if x is -1, y is -2. I can plot that as a point. -1, -2 is this point here. And then I can plot the next point, 0, -1. X is 0, y is -1. Remember, x is always horizontal axis, y vertical axis, so 0 - 1 goes there. Now let's plot the point 1, 0. So you go across to x equals 1, y equals 0 is just there. And then we can go x equals 2, y equals 1. That would go there. Notice that all of these points here that I've plotted lie in a straight line. That's why we call this a linear pattern. Similarly, if you were to plot these points 0, 6, 1, 4, 2, 2, you would see that the points lie in a straight line as they did here. It would actually be like this. It'd actually go in the other direction, but it'd still be a straight line. If, however, you plot each of these points, then they would not lie in a straight line. They would actually look something like that, not a straight line. So linear patterns are so called because if you plot each point, they lie in a straight line, but you can tell easily whether or not they're linear by just looking at, does y go up or down by the same amount each time? All right, let's look at some harder questions. So now we're going to find the missing value in each table if the pattern is linear. So because the patterns are linear, it means each time x is going up by 1, y is going up or down by the same amount. So -1 is halfway between 0 and 2. This number, if it's linear, has to be halfway between 4 and 10. Halfway between 4 and 10 is 7. So what's happening here is the y value is actually decreasing by 3 each time. So the next value will be 4 minus 3, which is 1, and then minus 3 again. This is a linear pattern. All right, let's look at what's happening here. So this is a tough one. X is actually going up by 2 each time. So how does that affect it? Well, notice what's happened here. X has gone up from negative 3 to positive 5. X has increased by 8. Y here has increased by 16. So when X increases by 8, Y increases by 16. This means that if X were to increase by 1, Y would go up by 2. So each time X goes up by 1, Y must go up by 2. That means each time X goes up by 2, Y goes up by 4. So I need to add 4 in this. X is going up by 2, Y needs to go up by 4. So that would be 6, 10, 14, and 18. So key to solving these problems here is you need to figure out how much does Y go up or down each time X goes up by 1. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.